All right, let's go ahead and take a peek into reconnaissance. Now within this, we're also going to be taking a look at some other things such as scanning networks. We're going to look at live systems, protocols, and also the enumeration side, all in this section. There's a lot of information to cover, so pay close attention. And remember, whatever we're seeing here, most likely you're going to need to remember. So try to remember as much as possible, take as many notes as possible, and kind of take it from there. All right, looking at the step one in the hacking life cycle. Now, if we look at the hacking life cycle, we basically have those 5 phases. I think we mentioned we have the 5 phases of the hacking life cycle. And this is basically starts off with the reconnaissance portion, also known as footprinting. And the whole idea of footprinting is to gather as much information about the target as possible so we can then go into the next phase, which is the scanning enumeration phase. This is basically where we use tools like Nmap and we do a little scan on our network or on the subnet, which would then allow us to see what machines are actually alive. And then from there we can enumerate and try to grab additional information off of those remote machines that we just identified as being alive or on the network. Then we get into the third phase, which is gaining access exploitation scenarios. So this is where we actually get into the systems and we actually try to exploit those systems that we've scanned and that we've enumerated. Then we also maintain access by adding in Trojans and rootkits and so forth, backdoors, and then we cover our tracks with phase 5. So when we look at what information is going to be gathered by the hacker, keep in mind this can be everything from online information sources to local social engineering to remote social engineering. Now we need to figure out things like who owns the systems. We need to find the system owners, who registered for the domain name, things of that nature. We need to also find out what types of systems are used, and we can generally find those out by looking at job advertisements or looking at the Wayback Machine, also known as the archive.org. And then we get into things like how big's the company, figure out if they've actually merged recently with another company that could allow us a possible in that we can maybe come in as the merged company employees, things of that nature. All right, we need to figure out how their sites communicate with each other, what type of phone systems they use, PBX systems and such, and whatnot. And then also need to figure out if the IT support is either going to be local or off-site. Right, and then also what's accessible from the internet. So what services, routers, DMZs, things of that nature can we identify while we're online. Now keep in mind when we're doing things like this, especially if we're doing some type of active reconnaissance, meaning that we're actually touching the target's website and things like that, you may want to consider using some type of anonymizer, and we'll talk about that here in a little bit as well. Always a good idea, because you don't want the target knowing your IP address, so you'd mask it by using some type of Tor client, some anonymizer, or some VPN client. So when we look at active versus passive, or passive versus active reconnaissance, passive reconnaissance is going to be known as the process of collecting information about an intended target without direct contact with the target. So this would mean going through the websites, search engines, things of that nature. Right? So active reconnaissance, however, is the process of collecting information about an intended target by making contact with the target through social engineering or electronic probing of the target system. So this would be showing up at the target, making phone calls at the target, things of that nature. So again here, footprinting defined. Footprinting, again, it's just the process of gathering data regarding a specific network environment, usually for the purpose of exploiting system vulnerabilities. Footprinting also begins by determining the location and objective of an intrusion. Then finally creating a network diagram and or company blueprint for later attack analysis. You can also check as a reference the searchsecurity.techtarget.com/sdefinition/0, SID14_GCI 546674,00.html. Okay. Now let's take a peek at social engineering and how we can also incorporate some of that. Now when it comes to the basics of social engineering, you should be able to answer any question that has to do with any type of social engineering type of question that comes up. Again, the the social engineering scenario is basically the practice of persuading people to believe you are someone you're not, to obtain confidential information by manipulation of legitimate users. Social engineers may use the telephone or the internet to trick people into revealing sensitive information or getting them to do something that is against typical policies. So keep in mind, in layman's terms, that social engineering is generally going to be the act of getting some needed information from a person rather than breaking into a system. Right? So you're not going to do it via digital means, or you're just going to be doing it via human means. So we're going to attack the human factor here. Hacker can obtain information about the target from the internet, newspapers, employees, employee family members, consultants, vendors, customers, and security experts. The method for obtaining information, again, this might be good to know, shoulder surfing, Wayback Machine, as in the archive.org, public websites, Yahoo people, and using various tools like Sam Spade or NeoTrace, for example. Just some social networking sites that you may have heard of before, MySpace, Facebook, LinkedIn, and so forth. Hackers generally will use social networking sites to try and find info enabling them to social engineer your target employees. Many of the people's accounts provide personal photos, very up-to-date details about their private lives, experiences, and behavior habits. Example here would be messages and photos about an upcoming vacation that can cue hackers into when physical access attempts should be made on the victim's home or even the office. Here are some people search engines you can check out. We have zoominfo.com. We have zabasearch.com. We have spock.com. We also have Wink. And you can also list more specialized people search engines by looking at the search-engine-index.co.uk/people_search. All right, and here it is, the Wayback Machine. Now, anytime you come across a scenario where you need to go back in time to figure out perhaps a web page that stated something about jobs, careers, and so forth, that may give us an inkling of information of what machines, what kind of infrastructure they have and so forth on the network, then you would go to the Wayback Machine, also known as the archive.org. Now, Google also has an option that you can look at Google cached pages. However, they're very limited. Anytime we want to go back a month or more, or even years, because it goes all the way back to 1996, you can check out the Wayback Machine, which is basically the archive.org website. It's a pretty nifty little product that is freely available online for you to use. And again, anytime you're looking for something that's a little dated back, you can use the archive.org. As I mentioned before, you can use also when you're targeting the website, doing your active reconnaissance, you may want to use something like Tor. And this is basically a network of virtual tunnels that allows people in groups to improve their privacy and security on the internet. It also enables software developers to create new communication tools with built-in privacy features. Here, a branch of the U.S. Navy uses Tor for open source intelligence gathering, and one of its teams used Tor while deployed in the Middle East recently. Now, law enforcement used Tor for visiting, surveilling websites without leaving government IP addresses in their web logs, and for security during sting operations and so forth. You can check them out at the torproject.org. And keep in mind, when you're using things like this, anonymizers and proxies are definitely going to be used, because they will go out and protect your privacy and identity when you're on the internet. It also allows you to possibly post negative entries in message boards, blogs, or whatnot without, again, leaving your IP address. And for some companies too, even though you may have a policy in place that prevents people from going to certain websites, you can also use this to even bypass applications that are blocking you or preventing you access to certain websites that you would normally visit and so forth. So you can definitely use that. A good example would be your Internet Explorer settings. You can actually change that around, add in your specific proxy server that you want to use. And again, with that, even if group policies are enabled on the network, you can still bypass those policies, security policies, by just putting in your own proxy and so forth. You can do a quick Google search on free web proxies out there, and you'll be surprised of how many results you'll get where you can actually use an IP address of another server that's out there. So whenever you're browsing the internet, you're going then through that other server to gain access to websites and so forth. Again, that may be restricted within the company policy that you have within the organization. So when we look at some of the footprinting tools and so forth, what we're going to be looking into, we're going to be looking at things like, obviously your search engines using Google and so forth. Looking at some Backtrack Kali scripts possibly, but doing information gathering there. Using things like Dig, which is basically the NS lookup tool within Unix. We also have the Whois side, which we'll look into more so. This is specifically to DNS. And obviously here we have NS lookup, which is the counterpart of Dig. And then we have NS lookup, which is the counterpart of Dig, and it allows us to do zone transfers even, and so forth, right? And then we also have Edgar, traceroute, and so forth that we'll look into. Again, we're going to check out some of these and take it from there. All right, so let's take a peek at some of the Google type of things we can do here, and I'd highly recommend that you try some of these out to make sure you see the results of the queries, so that way you have an inkling of an idea of what type of results will be used if you're trying to find certain types of information. So with some of the Google queries that we can use, there are some that are going to be very useful. Now whenever you're using Google and you're using different search operators, you can use the things like the site colon, which basically restricts the results to those web pages in a given domain. So let's say we have Google and we wanted to do something like site colon, and then we put in something like msn.com. Now you notice that all the results here that we put in are MSN because we specified msn.com, or at least that's msn.com within there. So other things, let's say we wanted to do something like ASA 5505. And then we do something like expertsexchange.com, for instance. Now it's going to go out there and find any kind of ASA 5505 specifically at the expertexchange.com. So all of our results should indicate the expertexchange.com website, which you can see here is the case. And they all have to do with the 5505 ASA. So we can definitely specify things. Now also what we could do is we could go in and do something like a file type :PDF. So it'll go out there and search for anything that's PDF related on the expertexchange.com, which there is none. However, let's say if we just did .com with PDF, and you'll notice here now we get results of our ASA 5505 with the site of .com. So every result here is a .com. And the file type is always going to be, in this case, PDF. So you can see here, we should have only PDFs as our options that we have. Plus, it's a .com, rather it's Cisco.com or whatever else. So that's what we're specifying here. Now we do have other scenarios. What we could do, for instance, we can put something in here like in title : So now what it's going to do, and you notice here we jumped from a couple thousand to 935 results, but when it comes to in title, it basically allows us to narrow it down to what is in the title. So when I click on one of these, it's actually going to be in the title here. So as you can see here, the Cisco ASA 5505, that's in the title, right? The ASA 5505, because that's what we specified here in the title. Now we can also use other things like, let's say we want, instead of using site, we want to use something like in URL. All right, so we do in title ASA 5505, in URL, I don't know, let's put in Cisco, something like that. And we can also put in something like plus in text VPN or something like that, and see what we get back. And as you can see, we get a few results back, as in 14,300. But what we're basically seeing is we have in the title ASA 5505, kind of like what we had here. We have in the URL of Cisco, right? So somewhere in the URL, regardless of where, it needs to have Cisco in it, which it does. And then within the text itself, it should have VPNs. So as you can see here, we see the text and it's mentioning the VPN, right? So again, when we look at some of these things, we need to be able to identify, again, looking at things like in title, in URL, in text, site colon, the things like even the file type, things like that. Right, so you definitely can find out some of these things. A lot of times we're looking at things like, for instance, index of MP3 or something like that. All right, so we can check out specific things within that. So again, that's going to be pretty straightforward when it comes down to using some of the Google type stuff. We also have the ability, rather than just doing in title, of doing things like all in title or all in URL, which basically restrict the results to those with all of the query words in the title versus just using in title, which uses restricts the results to documents containing that word in the title. So if you wanted to be more specific, you can do all of the query words in the URL, which makes it again more specific, takes down your search results, things like that. So just keep in mind as you're going out there and you're doing these things that it might be a good idea to take a look at some of the results that you get by using some of these operators. Okay, now let's take a peek into domain name registration. Now the DNS server, your domain name server, basically is responsible for keeping track of what name you put in to where it goes on the IP address. So let's say if I go to my command prompt here and I do something like ping mile2.com. Now, all I know is mile2.com. However, because of DNS and the DNS settings, it's able to tell me, in this case too, what the IP address of mile2.com is. And this has to do with DNS records, which we'll talk about here shortly. It is also very important to look into and get a little bit of idea from what that looks like. So in our case here, when we pinged mile2.com, the DNS server knew that mile2.com was at this IP address of 206.214.216.216. All right. Now, rather than us remembering this number, we just need to remember the name. And that gets kept track of by DNS records, which we'll talk about here shortly. All right, when it comes to domain name registration, this information here, you can check out the Aaron.net, the Appnik.net, and Ripe.net, which basically covers North America, South America. We have Asia Pacific and Europe and so forth as well that's being covered. And these are basically holding the repositories for IP numbers that are going to be used. So we have Internet, which is a repository for name registration. And it has basically delegated to about 250 registrars, and you can check it out at the internet.net alpha.html. So basically, when we pinged the mile2.com website, right, we have the domain name registration that was controlled by Aaron, for instance, that gave us a specific IP address that identified where we were, part of the world. Now here's some of the whois information that we can see. This basically, once we've actually registered for a domain name and so forth, and we put our information in, hopefully we were very generic with putting the information in and did not put personal information in that would allow a hacker to do some social engineering attacks against us. But either way, when you go to, for instance, the centralops.net website, you can actually find out some of the additional information, which we'll show you here in just a moment. Now, Aaron's database contains information on networks, autonomous system numbers, as in ASN numbers, network-related handles, and other related points of contact. Do not search on domain names here. Search on other information such as IP address or organization name and such here. So now we get into the DNS databases. Now they contain information about your fully qualified domain names and IP addresses. They also contain information such as which servers are the mail servers and Active Directory servers. What we basically have here, and there are a few others which I'll mention one or two more, but we basically have our record name. Record name of host, which is the record type of an A record. Now the A record generally just maps the domain name to an IP address. We have a pointer record, the PTR, which maps the IP address to a domain name. We have the name server, which basically gives us the information of the name of the server. A lot of times it's just going to be NS1, NS2 at whatever the domain name is .com or whatnot. And it identifies a server name for the delegated zone. We also have what's called the start of authority. Now the SOA record. This configures settings for zone transfers and record caching. And basically there's different things within the SOA, the start of authority, that you need to know. You need to look at the start of authority record and see what that looks like. Now it's basically broken down into the serial number, which is basically just a revision number, which also includes the date. We have the refresh rate, which is the refresh interval for secondary DNS servers. We have a retry, which is going to be the retry interval if zone transfers fail. We have the expire, which is how long until the secondary server will hold on to the record if it does not receive an update. And then we have, lastly, the TTL, which is the default TTL for the client name resolution. And as we look at the SOA record, you will notice that is going to be the order that it comes in. So you need to be able to identify something within there, within the SOA record. We also have the service locator, which is the SRV, used to locate services and servers on the network. And we also have the mail, as in your MX records. And the MX records are very important because they allow us to basically go in and do things like, if it's set up for mail relay, for instance, we can actually spam that mail server and use it as a spam server, more or less, because it has relay enabled. So anytime we see anything regarding SMTP servers, the possibility of you being able to use the command prompt, for instance, in telnetting into port 25, which is for SMTP, your Simple Mail Transfer Protocol, then that means we could possibly use it as a mail relay server, and with that, send emails unsolicited through that server. Pretty cool. Now there's one more here I want to mention at least. It's called the HInfo record type, and its purpose is to identify services that are running, as well as the CPU and the operating system itself, and such. Then we also have a text record, and basically we personalize information there that could be put into the text record, and that should do it for us. So make sure you are able to identify any of the record types and what they look like. Check out the centralops.net website to take a look at some of those records and what the results would be for that. Now we get into some other things, such as using things like NSLookup. Now keep in mind, NSLookup is going to be used mainly on the Windows side of things, and it is used to query your domain name servers. The output information can then be used to diagnose your DNS issues. However, hackers can use NSLookup output to determine what servers to target. Now, both Unix and Windows come with an NSLookup client, and it is built into many tools. Remember, on the Unix side, it is called DIG. Now when it comes down to it, we basically have what's called the traceroute operation. Now traceroute is going to be used to determine the path taken from the attackers to the target. And this is going to be doing by exploiting the TTL, as in your time to live, to get the target. Now we can use the traceroute command in the Linux world, or we can use the tracert command within the Windows world. And basically it gives us the path to the destination, and we're able to then route and figure out how many hops, and then also figure out to go from there.